Hello, my name is James Kindon. I am going to be doing a session on FSLogix and all the things you should know, with a focus on WBD. I'm a consultant in the modern workplace practice at Centra over in Sydney, Australia. I'm lucky enough to be part of the Citrix Technology Professional Program and a Microsoft MVP in Enterprise Mobility. Twitter, blog posts, all sorts of stuff referenced below. All right, jump straight into it. Go through some of the basics of FSLogix containerization, right? What it is, why we use it, and what the magic is about it, right? And this comes from, as we think back to, file-based solutions like roaming profiles that we've known for years, be it Microsoft, Citrix, whatever. These types of profiles live on a file share. They are streamed down to an endpoint for a user to consume. That user goes and does its work, alters that profile. At the end of the day, it logs off and puts that profile back to file share. Right. For the duration of the session, that profile tends to live locally on the server that the user is operating on, or on their Windows 10 endpoint. Container-based technology is very different. It basically mounts at logon by using a VHDX mount or a VHD mount, right? It's no copying of data back and forth. The container lives where the container lives. It's mounted, it's accessed, it's disconnected when the user logs off, right? And alongside these file-based versus container-based solutions, we have the concept of roaming profile and a local profile, right? A roaming profile is known by Windows to be roaming. You look in System Advanced Properties of a roaming profile, you'll see that the profile is aptly flagged as roaming. Whereas if you go and have a look under your local machine, System Advanced Properties, you'll find that your profile is typically flagged as local, right? And local, we don't have problems with local profiles. I mean, it's been forever known that roaming profiles around the place introduces headache and pain. Local profiles just do their thing. Happy users tend to be operating on local profiles on their local devices. And what FSLogix brought to the table and what makes it amazing was the ability to make a local profile portable. Right? So I tend to talk to customers about profile portability rather than roaming profiles, right? The profile roaming has a bad taste in most people's mouths. So, FSLogix did a great job of tricking the operating system into having a local profile made portable. Windows has no idea, has absolutely no idea that your container, that your profile is being moved to a container. C uses James, the operating system. It just happens to be redirected into a container. With that comes the considerations. Some good and some just things we need to watch for, right? And they're broken down into three categories here. So consistency and simplicity, they're obviously the good things. Capacity and IOPS are things we need to have a think about, and the outage impact, it's significant, right? So the good thing is FSLogix technology and VHDX technology as a whole introduces consistency. All right, and what we're looking for there is, over time, in a roaming profile solution, the more you throw at a profile, typically the bigger it got and the worse that it got from a logon experience standpoint. And we've all seen environments that have 2.5-minute logons because it's pulling down the profile. Containers, by the very nature, are designed to cater for a lot of data, just provide consistent mounting. Right? So it doesn't matter if it's a 10 meg container or a 100 gig container, the experience should be the same, which means catered for and sized properly from the outset, we should be able to walk away from projects knowing that what we left in place is typically going to stay the same, right? It just comes down to a scale game. The other good consideration here is that it's fast. Mounting a container is very fast. It's very rare that you're sitting there waiting for containers to mount unless you haven't catered for capacity and with a focus on IOPS, right? One of the big focal points here is that we have a direct transfer of IOPS. So users used to have all of their IOPS smashing the server where their profile lived, right? A multi-session environment, you have 15 users on the box. They're all operating locally on that box. They log off at the end of the day, and there's an I/O transfer back to the file system while that happens. But with containers, that I/O shift is huge, right? It's live, real-time spanking of wherever those containers live. So you have 15 users on the box. They are all writing back at the same time to the file share. Scale that, and you can see the implications of having undersized file shares. Capacity-wise, they are designed to cater for a local profile. So you are going to have a lot of data that by default turns up into an FSLogix container. It's very normal. We need to deal with that because we don't all have infinite scale at all costs. But with that capacity, we should still have our stability and our consistency, right? The big one here is outage impact. And I've seen many customers bitten by this. If you lose a file server in a traditional environment with roaming profiles, it's typically not the end of the world. Users can keep going, with folder redirection and stuff, they may be impacted. But for the most part, they're operating on the server that they've landed on. Containers, extremely different. You lose that file server, it's game over. Right? It is not a pleasant experience at all. Windows does not deal nicely with the loss of a VHDX. It does not deal nicely when you have 10 users on a box and they've all lost VHDX. Windows typically needs a reset to come back. So we'll go over some of the high availability considerations around that in a little bit. So there are two types of FSLogix containers. We have a profile container. Its job is to capture the full profile, so all user data, exactly the same as a local profile, right? It captures everything. So the user's James, every last bit of that goes into the profile container. We also have the concept of an Office container, which is a separate container used to capture specific cache data for the most point in Outlook, OneDrive. It's typically throwaway data that we don't want to back up or keep. And the Office container really made its mark where it turned up and was able to be used alongside existing file-based solutions, right? You could put it next to UPD, you could put it next to roaming profiles, you could put it next to Citrix technology. It was a bolt-on, and it gave us consistency and allowed people using traditional profile solutions to move into 365 and cater for the impacts of cache. Fun fact, if you look at the Office container on file system, you'll see it referred to as ODFC. It's the old Outlook data file container. It was really designed to handle OST straight off the bat and enable people to get up to Exchange Online. Office containers, we want to be really careful with where we position these and use these nowadays. If we're going to use them, and it's often the case, we still do use them, typically in scenarios where we don't want to be backing up a whole load of cache data, or we have different I/O profiles across our profiles and Office containers and the specific workloads. We only want to capture what is needed. Right? We don't want to be capturing things like Teams, for example, and we'll touch on that why in a little bit. We also want to try and let the profile interact as a profile as much as it can natively, right? So when we introduce Office containers with profile containers, we have considerations around the redirects, effectively the double redirects. So it's still a time and place for it, but most of the time we lead with a full profile container these days. Office container does have some considerations around differencing disks, which we'll go into in a little bit. The Office container does not leverage redirections XML, right? So you've got to think about this as we see it all the time. People have blown out their Office container sizes because they've got Teams redirection turned on into Office container. They've put in a redirections XML to try and deal with that. Doesn't work because Office containers don't care about redirections XML. So takeaway from that one is we really want to treat an Office container as a dumping ground for cache. We're not going to back it up. We're not going to replicate it. It's all data that can be recreated. Talking about differencing disks here, we have a concept of multi-access to containers, right? profile container and office container both have differencing disk capabilities. We need to be quite careful with them. You'll see type 0, type 1, 2, 3 thrown about a fair bit. Type 0 in a profile container world, it just refers to a direct normal attached VHD, right? One-to-one session between the computer and the container. Mounts the container, writes to the container, user logs off, container gets disconnected, job done. Type 1 gives us the ability to specify that we're always going to use a read-write copy. So we're actually going to go and create a differencing disk and always write to it. And that can be used in conjunction with type 2, which means in a multi-session environment. And when we say multi-sessions to the users, that user has multi-sessions across different workloads. We can specify that one of those workloads is going to be read-only, right? So we can throw away those changes afterwards. A read-write differencing disk is always merged back into the base disk. Type 3 in a profile container world is basically an attempt to read-write. So the first session that comes in is going to try and create a read-write disk and mount that one with a failback to read-only. Right? So if I can't get read-write access, I assume that someone else has already got it. So go and create a read-only disk, right? So that session can be mounted, can be used, changes are thrown away at the end. Type 3 in an office container scenario is a little bit different. It refers to a per session VHD. So there are certain workloads that we cannot put into differencing disks. OST files and OneDrive, right? I'm sure there's probably some others, but they're the two that stand out, that we do not put them in differencing disks. They do not deal well with being merged. It's not supported. So the Office container offers a per session disk. And what that is if I have a user that logs into two different session hosts, right, I can cater for their profiles using, a differencing disk scenario. Their Office container in a per session scenario is going to create two session disks. Right? It's going to have two unique copies of the OST or the OneDrive cache. It's going to treat them as individual disks. Now, obviously, that means double the capacity, but we can put some controls around that on how much we're actually going to retain and how many of those disks we're going to keep. Right? Each session disk is recorded as 0, 1, 2, 3. FSLogix always prefers session 0, and we can tell it to delete anything that's not session 0. The refs file system, if you're dealing with a Windows environment and you've chosen to use Windows file servers and you're using differencing disks, refs offers a huge amount of performance on merge operations compared to NTFS. They see a lot of collateral around the place talking about refs versus NTFS. The only real time you're wanting to be using refs with FSLogix is if you are using differencing disks, right? refs is amazing in how quickly it can merge those disks back together versus NTFS. So, yeah, differencing disks, fun. Typically, you're wanting to lead with the simplest approach, right? And that is typically type 0, normal direct attached VHDX. Permissions are very simple but often missed. There is a Microsoft document that just gives you the straight out, this is the basics that you need. We see challenges with modify. Typically, Gradio owner gets full control. We've seen modify break around the place. But the long and short is very similar to how we configure folder redirection or your typical roaming profiles, right? The user needs to have enough permissions to create their directory in their containers and then own it from there on out. No one else should be able to touch that except for administrators. Very, very basic. I've got a script that automates a lot of this. Aaron Parker has a nice write-up on the basic cackles commands to do this. Suggest heavily that you use a form of automation to configure these permissions so there's no form of skew, right? It's one of the most common problems that we come across is bad permissions on file shares. Some storage considerations, specifically focusing on Azure. You have three sure there's probably third-party others, but there's three that we'll look at. Azure Files, Azure NetApp Files, and Azure IaaS-based file services, right? So the Azure Files or the Azure storage accounts offer native storage, right? I'm sure we're all familiar with what they are. We can now do file services domain joined with no Windows file servers. That's awesome. Scale is really, really good. Backup is simple. Cost is less than running IaaS boxes. So it's just win, 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 win. Azure NetApp Files is sensational for scale. So if you have a lot of file services moving to Azure, a lot of storage accounts, a lot of data, you're looking at a minimum of 4 terabyte buy-in, but the scale is amazing. Perfect for FSLogix with a lot of workloads, right? Typically the premium ones are, the premium tier is where you want to be operating at. What NetApp can do with even standard tiers is amazing. We'll have a look at that a little bit later in a demo. But Azure NetApp Files is my personal preference for anything at scale. Right? We can do cross-region replication. We've got the old snapshots that we used to. We've got the brains of NetApp, but we've got it as a first-party service from Microsoft. File server clusters tend to be the last resort, right? And they are still perfectly valid. Not all regions support Azure Files or Azure NetApp Files. Some of them we are still forced to go and use IaaS file services to get the I/O and get the throughput that we need for FSLogix workloads. Shared access to managed disks has made clustering in Azure a lot better. So there's also architectural principles and what such. Right? There's a whole blog post that I put down below after working with a few orgs that will go into the ins and outs of each one. If we focus on Azure Files, we want to be looking at the premium tiers and making sure that we scale our capacity to I/O ratio properly. So storage accounts will scale per gig. So the more gigs you throw at it, the more IOPS you get. There is the concept of burst IOPS, which are really good for logon storms. We build up a credit system that we can use during logon storms. You don't want to be operating at those burst levels too much. It typically means you're undersized your shares. Blobs are available specifically for Cloud Cache. So in some regions where we can't use Azure Files premium storage and join them into a domain, we've got to stick with blobs. Cloud Cache unlocks that, so we'll have a look at that a little bit later on. Active Directory domain services and Azure Active Directory domain services are both supported. Where we can prefer Active Directory domain services, it just makes everything nice and simple. It's just like a normal file share. You can secure it the same way. Life just keeps going on as normal. James Rankin has a really good blog on how to access these file shares. If you don't have either of these services available to you, security is a bit questionable on it, but it does the job where and FSLogix supports computer-based auth if we need to, rather than user-based auth. And lastly, if we're looking at Azure Files, just be wary of the SKU limitations, right? We love premium file shares. They've only got LRS or the LRS replication capability, right? So when we think about it from a failover perspective or a HA and backup, we don't have GRS, so we need to start thinking, well, does Cloud Cache make a bit more sense if we need to go multi-region and all that sort of stuff? I would suggest having a look at automating your Azure Files domain joins. I've got a script here that will take away a lot of the pain, gives you consistency across your storage accounts, joins into Active Directory, takes care of all the not so great process that's currently there to get these things working. So I use this all the time across customers. If you're doing a lot of storage accounts across a lot of regions, this is nice and easy, repeatable, and it just guarantees every single time you get the same result. So with that, we'll jump into a quick demo of setting up Azure Files. Okay, so a quick demo on setting up Azure storage accounts for FSLogix workloads. It's just a brand new storage account deployed into Azure Australia East. It's a premium tier account. It's LRS. and it's an account kind of file storage. This account currently has no configuration on it, so it's completely out of the gallery. There is no ADDS configuration on it at this stage, doesn't even have a file share. So we'll go and create a basic FSLogix share, give it 100 gig capacity, so I don't choose here in my credit, and create. At this stage, we need to go and join it into the domain and configure it with the appropriate permissions. So I'm going to use a script that I've written previously to automate this. It is fed by a JSON input. So I fed it my subscription ID, my resource group, storage account name, the share that I've just created. I'm going to ask it to domain join the storage account using a computer account object. Stick it in a specific OU, and I've basically defined a group that I'm going to give contributor access to. Think of this as your share permissions. I'm also going to use that same group to go and configure NTFS permissions. I've got an admin account who's going to get the file share contributor and owner roles. I'm going to pull down the latest AZ files hybrid module, stick in a temp directory. I'm going to use the drive letter X to map the drive and assign the permissions. So quite a simple input. So join storage account to domain, PS1, switch to join the account to the domain, switch to configure the IAM roles. So think of this as your share permissions, switch to configure NTFS permissions. We're going to specify its JSON input and specify the path. So all things being well, we should be able to go out, connect into Azure. Here's my already authenticated session. That's my sub. I'm going to try and join this in. Success. Let's go through and do my SMB permissions. Success. Contributor. Success. Right, now dealing with my WVD users group. And now doing a quick test net connection to make sure I can talk to the account. Mapping a network drive, using cackles to go through and set the appropriate permissions, removing the drive, and we're now good to go. Now what this will have done is created a storage account for me under my Azure files. Here we are. It's created a brand new computer object for me. If we flick back to the storage account, what we'll see at this point is that it's now joined into my Kindon.com domain. Right, nice and easy, ready to take workloads, which we'll have a look at in a minute. Okay, so we have a session host up in Azure. I've logged in with an administrator account that is excluded from FSLogix containers. I have included my WVD users group in my include group. What we want to do is just make sure that our pathing is configured appropriately for Azure file shares. So you can see storage accounts, demo.file.core-windows.net, backslash the share name, some basic values. I won't go through what these are. Outside of the normal ones. What we're going to do, just going to attempt for the first time to log in with a user that's a member of my WVD users group and get them to go and launch our Windows 10 AZ files session. Take a little bit. If we go and have a quick look at our admin session, you can see that my disk's been created. So the permissions are set appropriately. We go back and have a look at the file system or the file share. Have a look at the file share itself. Just drill in a little bit. What you can see is that there is my user account coming in. So all of 2 minutes work to set up end-to-end from a permissions perspective. As long as your pathings are correct, we're straight in and we're good to go. And there we are, teams and all. So nice and simple. I touched on briefly Azure NetApp files and what it can do. And so what we'll do is, rather than talk through these, we'll jump into a demo and run through some of the cool things it can do in there. Okay, so a second quick demo, we're just going to have a look at setting up Azure NetApp files, just specifically for FSLogix container workloads. Now, NetApp files is first-party service supported and provided by Microsoft, brains of NetApp, just crazy amounts of scale, very, very simple. All right. So I have an existing NetApp files account in my tenant. I have an existing Active Directory connection. Very simple setup. Basically feeded a couple of DNS servers, feeded my DNS domain name, kindo.com, give it a computer account prefix, so ANF will scale files as it needs to. So giving an ANF as the prefix, giving it a specific OU I'd like it to create my file as in. I'm not using AES encryption. This is a previous service at the moment, as is LDAP signing. I'm using it anyway. I don't need any form of Kerberos for this demo. And so what we need to do is we run through in the first instance, going to create a brand new capacity pool. So a capacity pool from a NetApp perspective is a bunch of capacity, right? So different tier disks, standard, premium, ultra. Can give it a name, cap, standard, FSLogix demo. We're going to give it a standard tier for this one. You often find yourself probably using premium, although we can scale standard IOPS very, very high. Minimum buy-in of 4 tera. Create this guy. Nice and quick. So that's our cap pool that we can now create volumes on top of. This is where the fun begins. So we're going to go through and create a brand new vol. So volume, FSLogix demo. Give it a decent naming convention, standard. I'm going to use my standard capacity pool and give it 100 gig quota. I'm going to dump it into my existing VNet, which already has a ANF delegated subnet. I don't want to hide advanced snapshot paths. Protocol, you can either use NFS for high-performing workloads, but what we want is SMB. So I'm going to use my existing Active Directory connection. It's got a service account associated with it. I'm going to give it a share name of FSLogix, very similar to what we did with Azure files. Not going to tag this from a demo perspective. Confirm it's going to do what I want and hit the create button. This can take a couple of minutes to go through. What it's going to do here is create the volume. It's going to create the share. It's going to create a file in my Active Directory, at which point I'm pretty much good to go in and configure some NTFS permissions and then throw FSLogix container workloads at it. That's simple. ANF has a whole world of scale capability. It has cross-region replication. If you want to do snap mirrors, you can be doing premium source to standard destination, and it has all the usual backup technology that you're sort of used to in the NetApp world. So constant snaps, you can go in at any time, restore from Windows Explorer as required. But importantly here, it's the scale. The scale game for FSLogix is unreal, and what you can pull out from a standard capacity tier is very, very impressive. Okay, so after a couple of minutes, we are created. I'm going to have a look at the resource itself. We now have a mount path that we're going to take into our FSLogix configuration. We know there's an SMB share. basic configurations we had before us, and the FS security base share. So I'm going to grab our mount path here. I'm going to come and bake it into a group policy object specifically for this demo. Config, policies, admin templates, FSLogix profile containers, VHD locations. Done. The rest of my configuration is the same as our last demo. Activity update this guy. So once again, while that's updating, I have my WBD users in my include list. My dedicated session host here. Going to have a look in the registry and make sure our pathings are good. There we go, NetApp files row. So go and test that share quickly as well. Make sure we can actually talk to it, which we can. All right, and this is nice and simple. I've got an admin account, so I should be able to say create folders and delete folders at the root. Happy times. Okay, so I need to set some permissions from an NTFS standpoint to make sure that users can create their containers. We can't see everyone else's. So here's one I prepared earlier, the exact same process I take in our automated scripted domain join. So I'm just going to map a drive to NetApp storage and go through and just remove the appropriate permissions straight out of the Microsoft documentation. Disconnect that drive, and we'll go and attempt to launch a session. It's the same user. I'm just going to jump over to the ANF files session host, which is the one we're looking at already. Right, so session host is logged in. Teams is doing its thing. My images are all built by Packer, so they're effectively identical. But what we're looking for here is, again, we go back to the session host, it looks exactly the same. We can see that there is a profile container mounted for my session. If we go through and have a look at Azure NetApp files, here we go. You can see my container is there. There's my disk. What's cool about this is being NetApp technology, what we can do is actually drill down and have a look at the filer itself using computer management. So we can connect to it. We'll come in. We can then go through and have a look. If we want to create custom shares and folders and what's that, just once this connects in, we should be able to get our shares. And there's the share that we've created up in ANF. Point of reference, back in the Active Directory, refresh on my OU, and here is my computer account from an ANF perspective. So this will scale, create object as it required, or as is required. We're done. So scale of this is huge, right? So we can come back in. This will start reporting over time. We can resize these things. We can create new tiers. And as I spoke about before, there is the standard, the premium, and the ultra. Premium is probably the best suited for FSLogix workloads at scale. Ultra, you really need to be throwing a lot of data at it to justify that level of IOPS. Metrics over time, you can start monitoring this and see what it's doing. But yeah, that is the simplicity of ANF with FSLogix. So Azure file servers, so IaaS-based ones, basic Windows server clustering does the job really well. What you want to be looking at here is the shared disks capability on managed disks. Lets you configure file shares with continuous availability. You want to be looking at deduplication. So if you can push this on the server 2019, it has superior dedupe. And there was a reference architecture out there for a while with storage spaces direct and scale out file servers. They work and they're fantastic, but they're very complex compared to a traditional file server cluster. They do play slightly differently than they do with on-prem deployments. So we run into logon delays and all sorts of things, and Microsoft have dignified that things play differently with managed disks when dealing with SOFs and S2D in Azure. So if you can prefer shared disks and shared access to managed disks, you'll be in a happier place. FSLogix load distribution. You have the ability to, and you're going to want to do this at scale, distribute containers across multiple file servers or SMB shares as a whole, right? Be it storage accounts or not so much with NetApp files. You've got a lot of scale there. And file servers as well, right? We have the ability to distribute across multiple sets to give us better resiliency, better performance, and what such. We also have the ability to specify per user-based preferences, right? So we can tell a group of users to go to a certain set of SMB shares. It's all driven by group policy preferences. Is probably the easiest way to do that. I've got a blog post up on how to do that. I've also written a script to help with this. So this builds off the work of Ryan Reboard. He wrote some basic scripting to handle having a look at what shares had the least capacity and then change the ordering of VHD locations. James Rankin's got a great blog post up explaining the logic. My script here is, credit off to Ryan. This just builds on his work and puts in a lot more control and some selectivity around which containers to do it to and some capacity buffers and what sort of stuff. And the way that FSLogix works when it's dealing with multiple VHD locations is all locations are checked for an existing container. If there isn't a container, if there is a container found, use it for the user. If there's not, prefer the first defined available location. That means the first one in the list. Now, there is no cleanup logic in FSLogix, so if there are multiple containers due to outages or users moving around the place, there's multiple containers. FSLogix doesn't go through and clean this up. As I mentioned, group policy preferences are ideal when we're dealing with user segmentation. So just a basic example down below of a Sydney users group. We specify its SID and we specify the VHD allocations path for it. So my Sydney users go to Sydney, Melbourne users go to Melbourne, right? This isn't particularly used for high availability. It's more, it can be, but it's more aimed to do load distribution, right, and target people to be as close as they can to their containers. I have a whole blog post on, it's aging now, but it's looking at the high availability options and disaster recovery. HA for FSLogix is absolutely critical. VHD locations offer no user failover without storage HA, right? There's no, this one's not available, use this one. Once the container's already up. Game over if you lose one. Depending on the storage technology underneath will depend on how you can achieve that storage HA. If you're looking at synchronizations options, BVCK up 2 is by far the best thing for dealing with replication. It destroys BFSR. It can do block level, real-time replication of containers that are mounted. And Cloud Cache plays a huge piece when we're talking HA and DR, right? We want to prefer PaaS offerings, so Azure files, Azure NetApp files, just given the inbuilt resilience and availability they've got. If you can't use the PaaS, we move to clustering. Please try and avoid anything to do with single file servers. It's just not much fun. DR can be provided by using multiple VHD locations. This is DR, it's not HA. And if we think about the slide before, we look through how FSLogix actually determines which container to mount. It's not HA. Cloud Cache, we'll touch on it a little bit more. It's becoming more and more prevalent now that it's fixed and works really well in Azure. Some basics around Cloud Cache, what it is. Its job is to provide resiliency against the loss of an SMB file share. Right? It's primarily badged as I've got a session up, I've lost my file server, I can keep going. It has been the golden goose of EUC for a long time. It's enabled active data centers. It's enabled us to end up in a supported fashion with active data centers, but it's not the default deployment method either. FSLogix Cloud Cache should be a conscious decision, right? It's not because we can, we're going to. We want to do it because we need to. Those triggers, as we touched on, tend to be your multi-site active locations, or in Azure deployments where we need to be thinking about cross-region failover. Right, so we need to be thinking, I've got 2 data centers, Sydney, Melbourne. My failover is over to Melbourne. Cloud Cache can allow me to write simultaneously across to both locations. And then the way that I order my Cloud Cache locations at the machine level will determine which one it uses in which scenario. Right? Very, very good. Need to be quite sensitive and quite cognizant of, again, another I/O change here. So previously with VHD locations, we write directly back to our SMB shares. With Cloud Cache, we still do that, but we also write locally, right? So we queue our reads and writes locally, and we then push them back to multiple locations at the same time. That means we need high-performing disks locally. If you try and do this with cheap SKU VMs, the performance can be not so great. Azure, a lot of the machines we'd be using in WVD offer a level of temporary SSD that is absolutely perfect for putting our proxy locations on. So where our writes proxy through, it's a free disk that's sitting there waiting to be used. Had great success moving Cloud Cache proxies across to those disks, right? Making use of that thing that's sitting there. They're temporary. The data is flushed when the machine reboots, but who cares? We don't need anything persistent. We just need high-performing disk. We also need to be thinking about is antivirus. So a lot of people, when they move from VHD locations across to Cloud Cache, AV can get in the mix and cause all sorts of problems. There's extra directories we need to think about. We also need to be conscious if we change that proxy location, we need to exempt those proxy locations as well. And the last thing on this one is the slowest performing file shares will typically mandate our log-off speed. So Cloud Cache comes with a tax, right? It's not a huge tax anymore. It used to be. It's now a couple of seconds when it's configured properly. So there is a bit of a log-on tax, but there's also a log-off tax, right? Because we need to flush our writes down to our storage accounts or our file shares. The slowest responding file share typically mandates when we can log off our machines. So what that looks like, if you visualize it, if I have a high-performing file share in Sydney and I have a slow-performing file share in Melbourne, because it's there for DR, I'm actively writing to both of those locations. I hit the log off button, I'll flush down to Sydney really quickly. It's going to take me a while to potentially flush down to Melbourne. So there is a bit of a log-on tax there. But Cloud Cache, very, very good now that it's stable. Have a read of that blog post previously, which will take you into some more considerations as to when you would use it. A bit of a side topic on Windows search when we're dealing with containers. So Windows search roaming, it's all good and well that we can take a lot of data and make it quick in a container and mount it well. It's all good and well that we can have OSTs that roam a whole stack of data from a cache perspective. Windows search is critical to the user experience. So FSLogix with Windows 10 or even Windows 10 Server 2012 R2 onwards, up to 16, offered the ability to get in, grab a hold of the user search index, and actually roam it as part of the container, right? Windows 10 multi-session and Windows Server 2019 fundamentally changed that architecture, right? Microsoft now offer that ability natively, and they handle it within the operating system itself. So it's really important that when we look at WVD from a multi-session perspective and Windows Server 2019, that we don't turn on search roaming from an FSLogix perspective. We want to leave that as not configured. If it's been turned on previously, you want to turn it off, right? We do not want FSLogix trying to do search roaming when the operating system can handle it natively. Very quick side note, there is some differences currently between the way that Azure VMs handle search roaming versus on-prem VMs. There is a hotfix coming thanks to Jim Moyle and the work that he's done to work with Microsoft support and actually get them to dignify a problem and create a hotfix for that. So we should have feature parity very soon. But the good thing is, from a WVD perspective, search roaming is very, very stable. Some basics around troubleshooting and management of containers. All logging by default goes into C program data FSLogix logs. It's a very verbose logging system. It's just moved over to ETL. Turn on all logging. You'll thank me for it the day you go troubleshooting. Right. Container maintenance is a big topic in itself. Some really high-level notes. Redirections XML is the Microsoft or FSLogix answer to taking data out of the container and throwing it away. It needs to be used selectively and carefully. We think back to the whole concept of why we're using profile containers. We want a local profile in a box. Redirections have their time and place, right? It's great to get rid of useless data like Teams cache or Chrome and Edge cache, but you really don't want to be going berserk and importing every single exclusion you had from your roaming profile, right? It's a balancing act here. Stick with simplicity. The minute you have problems, turn off redirections and test again. Pruning the profile is a concept that Aaron Parker founded, which is more about how do we get in and manage the huge amount of useless data that is going to land in my profile without breaking the functionality of a container, right? And his concept is basically this. Learn what your profiles are going to contain, define the data that you want to prune or remove, and do it within the user session itself, right? Do it proactively. You can get selective with how you do this, what you do it to. Can be driven by group policy, logon scripts, all sorts of stuff. You've got a fantastic write-up, which I'll reference at the end, which is a proactive guide to maintaining this stuff. Last one on maintenance is user offboarding. Suddenly, offboarding users and the data that they have left lying around is quite critical. Right? If I've got 10 users that left the org, they've got 20 gig worth of data each, that's 200 gig worth of data I'm typically having to pay for somewhere in Azure. So offboarding processes need to be thought about. Antivirus, silent killer, again and again and again. I'm not going to go down and name the main culprits. It changes per year, but be very cautious of antivirus. And just watch for profile bloat, right? Teams, Chrome, Edge, anything based on the Electron framework, they're going to bloat these profiles. So marry it up with a strategy such as pruning, get on the front foot with it. You'll be in a happy place. A really low-level example of what I know is a safe redirections XML is one that I use all over the place. It deals with nothing except Chrome, Teams, and some very, very basic known CRUD. Right? This one tends to be safe. I use it everywhere and I have no issues. You're welcome to use it, add to it, but just be wary of some of the ones that are out there that are, the old days of UPM and roaming profiles imported everywhere. Antivirus, Microsoft have a documented set of exclusions. Again, just be cognizant if you're doing things like Cloud Cache and moving the proxy directories around the place. Aaron's profile pruning, and in fact his whole guide to capacity planning is amazing, right? He's giving you an entire framework that you can go and download and import, get going. Very, very good. Jim Moyle also has some fantastic scripts available, which I'll link off to, around shrinking the profiles. Right? There's a few tools out there. Jim's is probably the best. I'll link off to that one at the end as well, and that's for coming back and dealing with profile containers once they've had their space used. Right, it doesn't automatically come back. We need to go through some maintenance operations. So I'll link off to some of his stuff as well. Right, so very conscious of time. I have gone over. I just wanted to call out a few community resources that you can lean on and get assistance if needed. So the World of VUC Slack channel is founded by myself, Jaren Gibson, Dave, Brett, and Ryan Reboard. That is a hugely immensely helpful platform that you can get some help from. I got a load of ramblings that I put up at jkindon.com. Aaron Parker has led the fray for a long time. That's stealthpuppy.com. Jim Moyle, he's got some amazing YouTube content. I'm posting just a direct link off to the FSLogix shrink disk, but Moyle does a ridiculous amount of work in the community. James Rankin, his work is phenomenal, very good in all of this space. Manuel Winkle, newly founded CTP, has a great set of blog posts on the basics, and so does Casper Johansson. I'm sure there's others. I've missed out a few, no doubt, but I just wanted to call those boys out. Great amount of content there, and all of them are regulars in World of VUC. So thank you for taking the time. I apologize that this has gone over. I hope this helps out. Enjoy the rest of the sessions. Cheers.